Hey folks, Jonathan here. Just wanted to show you where I was at on the wiring of the generator. Okay, so we have got the volt gauge in, the amp, and we have to run a shunt with the amp gauge for it to work. And we've got our rheostat, and I've got two bulbs mounted. Now we're not running these bulbs. These are actually 12 volt DC rough bulbs, but I want clear Edison style bulbs. We've got the old ceramic fixtures, and we've got our knife switch here, which I think I'm going to raise up a little bit. I've only got one bolt in it, everything else is bolted permanent. And we've got to put our shunt on. And for anybody that don't know what a shunt is I don't think I explained it in another video, but you got to have a shunt to operate a amp gauge and on DC. So this is 400 amp, 50 milliamp. And so I had a shunt that was a 300 amp, 50 milliamp, but I didn't want to chance it because you're supposed to have it matched. So I bought another shunt, and this new old stock. So this goes right in line on your positive side, and then your wires go into your amp gauge hooked to these two small wires. And what it does is this takes the major load, so it don't pull the load through your amp gauge and burn it up. So we'll get it mounted. It'll just run on the positive line, and we'll have to run, like I said, two wires off of this onto it. Now I'm probably going to run this on the outside, and we'll just drill holes and run the wires through. It's pretty simple. Now everything on the gauges is wired from the back side. The light bulbs will be wired from the front side. And this, I've already got one wire on the rheostat running through the panel. Got to run another one out of it. It will go to actually right up to power, because the wire that's running there is actually running up. And I built some pieces. I'm not through. I'm going to make some more, but these are actually made out of some plastic. And what I'm trying to do is keep all three of these wires separated. This is cloth wiring. Now it's not in terrible shape or anything like that, but DC's been known to throw arcs, so I don't want these wires touching each other. I don't want even the coating to touch each other. It's going to come down and run into right into our machine right here. So we'll just have three wires running straight up, and then over, and then down, and then I'm building around this with wood. Now this is solid slate, non-conductive, and I've just got this angle iron frame that I built, and I've just got little tabs coming down here, and this does not go behind it. The only thing that goes behind this slate is in four little tabs that I've got for bolting it on. And once I get all the wood done around it, it'll look really good. Just using what I've got. Now I've got some receptacles coming. We're going to go over here. I've got a piece of phenolic plate, but I've also got another piece of slate I may use. But we're going to go over to this side and put some more of these knife switches. I'm going to put some fuses, and I'm going to put receptacles, and that way we can plug into. So the problem with DC is, because it's known to arc, if you use a AC fuse on a DC system, if it burns up and they're still close, that arc can jump it. So it's not gonna work. You can use a DC fuse in an AC system, but not the other way around. Most, but I mean they do make fuses that'll work, so we will be running the right fuses for our system. So anyway, we're going to keep at it here, and I'm using cloth tape on everything, of course, and we've got one junction done here for the field wire. As you can use it, I'm using these, I think they're called split bolts, but they're really nice. You can really tighten these down and get a good connection, and tape everything up really well. So when I'm done, I'm hoping this is going to look a little better than it looks, of course, but we'll see. Alright. Okay folks, been working away on the panel box. Got my switch wired in. It's my main switch, so when this comes on, it's going to feed two lines coming out of here and go into a receptacle box that I set up with fuses in it. So we got a rheostat here, and it's hooked up and ready to go. I've drilled it, wired it through here. Amp gauge is on. Here's our shunt. I'm going to actually drill I could have put this on the back side, but you know, you're trying to cover up space anyway, so we'll drill 2 holes here, run the wires through, run them to the back of the amp gauge, and that should do it. Now these are, the power runs through one end and out the other on this, and then that'll give us another place to shock ourselves. And let me see, light bulbs. These are not the right light bulbs. These are 12 volt rough duty. Just got them in here because that's all I had right this second. So I'm going to wire this one in to power when you flip the switch on. That way I can stand way back here and I can see that you know, whether this is on or not just by a light. And then this light is going to get wired into the power, so it comes on only when, you know, when we're making power, but it'll come on even when the switch is off. So that'll work out good. Let me see. I want to put longer Edison bulbs, taller, you know, bigger bulbs in this eventually. And let me see, I got a, oh, let me show you what I've done. You can laugh at this. Okay, I wanted to put the rheostat field wire on a knife switch, a single pole knife switch. And so I ordered one, and you know, pictures just sometimes don't tell you everything, especially if someone takes the pictures really close up. And so I ordered one, and I don't think it's going to work. It's tiny. I don't think it'd look good on this board. Even though it would hold the amps that we're running, I'm still not going to use it. So, but yeah, you can laugh at me for that. But it is cute now. I'm going to keep it. I'll use it for something. Don't know what I'll use it for. I'm not going to say if I need to, because I know I don't need to, but I'll probably go ahead and get a single knife switch eventually and change it out. So I've got some old school receptacles I'm going to use. I've got some old school fuses. I think most of these lights has actually got bus fuses in line, right in the cord, because I actually have already blown one. And I blew it because I think I ran this thing up to 140 volts one time by accident with the lights on and popped one of them, but my own fault. So it didn't like the extra voltage, I guess, for some reason. You would think it would handle the voltage, it just wouldn't handle if you shorted it or amperage, but it, you know, a big load on it, but it blew it for sure. So anyway, it is what it is. Alright, I've got a cover made for this too. I'll show you what that looks like in a few minutes. Okay folks, here it is. It's just made out of old pieces and parts of an oak fireplace mantle, as you can tell. But we needed some kind of a cover around it anyway, so just used it. Looks alright. I mean, nothing great, but it's fine. But got all my wires separated, and even if they look like they're together, it's just because of the angle, but they are definitely separated all the way down. Made some more pieces, and we've got some more taping to do here, but we've got it. And we're probably going to fire tonight and try it, just see what happens. Alright folks, we got the board working here. Do not have an amp gauge yet, don't know why. I'll have to work on that a little bit. I mean, it may not be any good, I don't know. Volts working. Got her on about a little over 100 volts right now. This switch is working good. You can see. The way I set it up is, this shows me that we've got power, and then we kick this one in. And that just shows us that we got that on. So that'll work. LED is still working. Just got a couple little bulbs plugged in. So most of them up. So, alright, we got governor work to do. We got some more taping and wiring and stuff to get this stuff looking a little better. We'll check into this amp gauge, see what's going on with it. And not a big issue. But anyway, should start getting some receptacles and stuff in here soon. Alright folks, we're just playing a little bit. We're let's see, we're down, we got 10 psi. We're still producing electricity. I'm letting it go down here because it's time to quit, but he said the amp gauge will figure out. I plugged my drill into this big 1/2-inch drill and brush style, and it ran it just fine. So anyway, that's 70 volts. Them bulbs there are just they're little cheap bulbs. It was actually called like rainbow bulbs or something, like a kid's bulb. and this one was in my grandson's room, and it burnt the paint on it, or whatever they had on it. It was blue and, you know, different colors, but that one still got the blue on it. But they're not much of light bulbs anyway. But anyway, so that's where we stand here. Let me get this thing shut down. I want to talk a little bit about the governor on this. Okay, folks, I know it's dark, but I'm going to try to show you with this light best I can. You can see the chain that's on there. That should not be a chain. It should be a spring. And what happens, and how this works. Okay, this is a weight that is adjustable. You can slide back and forth on that bar, and it changes the amount of pressure it puts on from centrifugal force. And the farther out, the stronger it's going to be. The closer in, the weaker it's going to be. So what we're going to do is, first I'm going to pull that weight off. I'm going to try to weigh it. We're going to weigh a weight and see if we can find out what the center of this to the center of the flywheel is, and try to get a little bit of an idea of what kind of mass we're working with when it comes to rotating at 350 RPMs. And I think with the distance out and the RPMs and the weight of it, I think I can get close to a figure of, so we'll know what spring we need to put on here. And we can adjust for it using that. It's probably going to be something like a hood spring or something. But what this does, just so you'll know, okay, I'm adjusting through the throttle. So I'm doing the same thing as a governor would do if it had a fly ball governor, you know, belt driven with the balls on top. So, you know, when I need a little bit more RPM, I just open the valve up. Now, we don't want to have to do that. And one of the reasons they made these automatic engines is, you know, you can't stop it and change the speed, but, you know, the governor picks up quick, and it adjusts to changes really quick, and the way that these are set up. So what this does, it allows you to keep 100% of your steam pressure in your steam chest. And what this adjusts is your length of stroke and timing somewhat. What happens is your eccentric, if you see the slot opening in the center, what happens is it actually moves that directly, well, almost directly in and out, but it pivots on another pin on the far side. And what that does is it brings the center of this eccentric closer to the center of the crankshaft, which shortens the stroke, and again changes timing to a certain extent. And you know what we're doing, or what it does, is it keeps 100% cylinder pressure in the steam chest, or 100% steam pressure of whatever you're putting in it, but it adjusts the timing and the stroke of the valve to put the RPMs down. I don't know that that is more efficient or not more efficient than throttling. I think it would react quicker, of course, on the governor, but you know, I don't know when it comes to steam if it's going to make a difference of saving more steam or less. And but anyway, that's what we're going to get into next on this thing. Put a spring on it and try to figure it out. Appreciate everybody watching, and until next time, bye.